What's up, you freaking geniuses? So in this video, I'm going to teach you how to evaluate trig functions given it a point on a terminal side. All right. So here the problem just says let -3, 4 be a point on the terminal side of theta. Find all 6 trig functions. So to find the sine of theta, that's going to be equal to y over r. Cosine of theta is x over r. Tangent of theta is y over x. Cotangent is just the reciprocal, right? X over y. And then secant is r over x, and cosecant is r over y. So as you can see, we have 3 different variables here, basically, right? So we have x, y, and r. So those are the 3 things we need to find. And then we just plug them into whichever trig function we want to solve for, and that's how we solve it, all right? So how do we find x, y, and r? Well, x and y is simply going to come from the point that you're given. So in this problem, x is going to be equal to -3, and y is going to be equal to +4. Let's just write that out. And then r is going to be equal to the square root of x squared plus y squared. All right, so in this case, r is going to be equal to the square root of x squared. Again, x squared is -3, and that's going to be squared, plus y, which is +4, and that's also squared. All right, so then here, -3 squared is +9, and 4 squared is 16. So here we get the square root of 25, which is equal to 5. All right. So now that we found those 3, now we can finally start evaluating these trig functions. So first, let's find the sine, cosine, and tangent of theta. All right, let's find those 3. So first of all, the sine of theta is going to be y over r. So y is 4 and r is 5. All right, so the sine of theta is equal to 4/5. The cosine of theta is x over r, so that's going to be -3 over 5, or we could write that, we can just put the negative sign out in front, so we could write it as -3/5. All right, either one of these would work. And then lastly, the tangent of theta is y over x, so y is 4 and x is -3. So same thing, we can bring out that negative sign to the front and just write it as -4/3 like that. Now let's find the other 3 trig functions. So the reciprocal of sine is cosecant of theta. The reciprocal trig function of cosine is secant of theta, and the reciprocal of tangent is cotangent. Okay, so since we know these 3, right, sine, cosine, and tangent, in order to find these 3, it's going to be the exact same. We just have to flip them. All right, so the cosecant of theta is going to be, instead of 4/5, it's going to be 5/4. All right, notice this one was positive, so we still keep it positive. Okay, now for the secant of theta, cosine is equal to -3/5, so the secant is going to be equal to -5/3. Again, it's negative, so it stays negative. All right, and then lastly, here for tangent, we have -4/3, so the cotangent is going to be equal to -3/4. All right, let's try one really quick one where we have a radical, just in case you come across one like that, right? So this is going to be the exact same problem. The only difference is the coordinate changed, right? So this time the coordinate we're given is 2 and the square root of 21. So again, the first thing, in order to evaluate our trig functions, we just need to figure out what x, y, and r are, all right? So here x is going to be equal to 2, y is the square root of 21, so let's just write that down, +2, and the positive square root of 21, and then again, r is equal to the square root of x squared plus y squared. So in this case, r is going to be equal to x squared, which is 2, so 2 squared, plus y squared, which is the square root of 21, and that's squared. So then here, 2 squared, that's equal to 4, so we get the square root of 4 right there, plus, and then whenever you square a square root, those just cancel each other out, and you're left with simply what was inside the radical, so that's just 21 in this case, right? So here, this is going to be equal to oddly enough, the square root of 25 again, which again is equal to 5. All right, so here r is equal to 5. We could just write it right there for reference. X is 2 and y is the square root of 21. All right, so again, if we want to find the sine, cosine, and tangent, the sine is going to be, again, y over r. So y in this case is the square root of 21 over r, which is 5. The cosine is x over r, so x is 2. So here we're going to have 2 over 5. And the tangent of theta is going to be equal to y over x. So y is the square root of 21, and x is 2. All right? Now, when we find the other 3 trig functions, right? So we're going to have cosecant, secant, and cotangent. All we have to do is flip these, all right? Now, the only problem here when we flip these is we're going to have a radical in the denominator, all right? So for instance, cosecant is just going to be the same thing as sine. It's just going to be flipped. So here, cosecant is going to be equal to 5 over the square root of 21. All right. Now the problem here is we can't have a radical in the denominator. So what we have to do here is something called just rationalize the denominator. And the way that you do that is by simply multiplying this radical on the bottom and on the top. Okay, so now let's multiply these together. On top we have 5 times the square root of 21. So that's going to be 5 times the square root of 21, and that's going to be over the square root of 21 times the square root of 21, which is equal to simply 21, all right? It's kind of like saying the square root of 4 times the square root of 4 is equal to just 4. How do we know that? Well, the square root of 4 is equal to 2. The square root of 4 is equal to 2, right? So 2 times 2 is equal to 4. So the same thing over here. The square root of 21 times the square root of 21 is equal to just 21, all right? So then this would be our final answer for this trig function. And I'm not going to do the last two because it would just be the exact same thing. We just have to rationalize, not for the secant, but for the cotangent, we would have to rationalize the denominator. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.